Alright guys, so we are looking at systems of equations in this first section. Today we're going to kind of just review the idea of solving systems of equations through elimination. You guys did this a little bit in Algebra 1, so this should be pretty familiar to you. So I just kind of want to walk through the process of just solving a two-variable system of equation. Okay. So here's just an example. We started off with this system in which we have 3x minus y equals 6 and x plus 2y equals 5.5. And the goal with elimination is to try to get rid of a variable. So like we could either get rid of the x's or we could get rid of the y's. So in this situation, we're trying to eliminate the y's. And the way we do that is we look at each of the y values. So we look at y and we look at 2y and trying to think of, is there a way to make those two equations opposites? Well, right now there's a -1 in front of that y, and then there's a 2 in front of this y. So in order to make these two equations opposite, I could multiply this top equation by 2 because it'll make it the opposite of 2y. Because if I multiply 2 by -y, it makes it -2y. So I multiplied this first equation by 2 to create a new equation, 6x minus 2y equals 12. Well, because these two y's are opposites of each other, I could add them together, and I get 6x plus x to get me 7x equals 17.5. And then if I divide both sides by 7, I get x to be 2.5. So if I know what x is, then I can find out what the y is by just plugging 2.5 in place of this x. So I have 2.5 plus 2y equals 5.5. And I solve for y. I get 2y equals 3, and then I get y equals 1.5. Well, if you guys were to notice, like in this case we eliminated the y. Well, I could also eliminate the x, and that's what we're going to kind of look at next. So in this case, I have a 3x, okay? Well, the opposite of 3x is -3x. So what I could also do is I could multiply this equation by -3. So if I multiply this first equation by -3, I will get -3x plus -6y equals -16.5. I'm going to put the top equation right above it. So I have 3x minus y equals 6. So, in this case, I have the x's and they cancel out, so I'm left with -7y equals -10.5. Alright, so I'm going to divide both sides by -7, and if I divide both sides by -7, I get y to be positive 1.5, which, if I go backwards and just check, hey, guess what? I got y to be 1.5, so it did work out, okay? So I know what y is. I know y is 1.5. Now I want to find out what x is. Well, that's a stupid thing, Mr. Graham. We already know what x is, but I could also work back. I could use this y value to do that. So I'm going to plug into that second equation. So I get x plus 2 times 1.5 equals 5.5. So I have x plus 3 equals 5.5, and I get x to be 2.5. So that checks. I got 2.5, and I got 1.5. All right, so let's just look at another example, okay, with kind of looking in this situation. This is on page 2 of your notes. So I'm looking at these x's, I'm looking at the y's, and trying to think of, hey, what's the opposite of 6? Well, the opposite of 6 is -6. Is there anything that I can multiply -2 by to make it -6? And there is. I can multiply it by 3. So I'm going to eliminate the x's in this case. Because if I look at these y's, I got 15 and 7. And it's hard for me to think of a number that both goes into 15 and 7, okay? So we're just going to work with these x's. So I'm going to multiply that top equation by 3. I get -6x minus 21y equals -3. And then I got 6x plus 15y equals 15. So when I add these two equations together, I get negative 6y equals 12. So I get y to be negative 2. So I know what y is, now I have to find out what x is. It doesn't matter what equation I plug it into. So I'm going to plug it into this top equation. So I have negative 2x minus 7 times negative 2 equals negative 1. So I got negative 2x plus 14 equals negative 1. So I have negative 2x equals negative 15, and I get x to be 7.5. If I wanted to check this, I could check it in the second equation. I could take 6 times 7.5 plus 15 times negative 2 and see if it equals 15. That's the hope, right? 6 times 7.5 is 45 plus negative 30 equals 15. So it does check out, okay? Now sometimes, like in this case, it's easier for me to figure out what to multiply both equations by. I just have to multiply one equation by multiplying one equation. Well, in this case, if I look at like 4 and 6, and I go look at negative 3 and 5, it's a little bit harder for me to figure out, well, what can I multiply 4 by to get it to be the opposite of 6, or multiply 3 by to get it to be the opposite of 5. So, like, we can work with fractions or decimals, and it works out okay. But there is another trick, and I can multiply both equations by something. So, like, if I look at 3 and 5, well, I know 3 and 5 both go into 15. Well, I can multiply this top equation by 5, because that's going to make this y value a negative 15. And I can multiply this bottom equation by 3. So I get 20x minus 15y equals, 90. And then I got 18x plus 15y equals 24. So if I take 20 plus 18, that's 38x. Those two y's cancel each other out, and I'm left with 114. And if I divide both sides by 38, in this case, I would get x to be 3. So if I know what x is, then I can find out what y is. So I can do 6 times 3 plus 5 times y equals 8. So I have 18 plus 5y equals 8. So I got 5y equals negative 10. So you get y to be negative 2. So my solution is 3, negative 2. Okay? All right. Now I could have done it the other way, and I would have gotten the same thing. Okay? So what I'm going to ask you guys to try to do, I'm going to ask you guys to try these, which is on the same page, looking at finishing up page 2 of the notes. So I'm going to ask you guys to try 1 and 2. We'll talk about them when I see you next.